Hello everyone, Mr. Fussett here, and we are back with another Algebra 1 lesson. Today we're actually starting a new unit. It's going to be on inequalities, so it's probably something that you've at least discussed a little bit before in a pre-algebra class, but we're going to go a little bit more in depth in our algebra class. To get us warmed up, you have two inequalities below. We have number 1 and number 2. First thing you're going to do is translate them into words. So can you rewrite these in words rather than numbers, symbols, and letters? Then, if they're not already solved, go ahead and solve them for me. So take a couple minutes, pause the video, then come back and see how you did. Okay, so I'm just going to type these out because it's a little bit easier. And there's a couple different ways you could write this. One would be saying that x is less than 8. We don't have to specifically say x, we could say a number less than 8. So something like that, you should probably use the words less than, because that's the kind of sign we have here. We're saying that some number is less than 8. All right, nothing else to solve here because x is already by itself, so this inequality is already solved. If we go over to number 2, I'm going to start this down here because we are going to have to solve this one. Let's think about how we can write this. So our x is on the right-hand side, which means that x minus 5 is less than or equal to 12. So we can say the quantity of x minus 5, and you can put that x in quotes or quotations. The quantity of x minus 5 is less than or equal to 12. You could also say the difference between x and 5 is no more than 12. So saying no more is the same as saying less than or equal. And you could tweak these a little bit with some different words here and there, as long as they match the inequality up above. And then we need to go ahead and finish solving this. So I'm going to get the x by itself. I'm going to add 5 to both sides. And I'm going to get x is less than or equal to 17. Now, what I like to do is whenever I start to read an inequality, I always start with the side the variable's on. So in this case, the variable's on the right, so I'm going to start with that side. All right. I think it's just easier for people to understand than if you said 17 is greater than or equal to x. Okay, it's a little bit easier when you say x is less than or equal to 17. At least I think so when I think about how most students tend to understand these. So I usually just start reading from the side that the variable's on. Okay, let's move on. So you have a question to answer. We solved number 2, right? So we used an inverse operation. We added 5 to both sides to get x is less than or equal to 17. I want you to think about, are there any similarities and any differences in terms of solving inequalities versus solving equations? So obviously we have one similarity, right? We used addition, the addition property of equality. We added the same thing to both sides for number 2. We added 5 to both sides, which would be exactly how we solve an equation. So maybe there's some other similarities, but maybe there's some differences. Maybe you don't always solve inequalities the same way you do equations. So think through that question for a minute or two, write down any thoughts you have, and then come back and we'll have a discussion. All right, so I just typed in the key differences and similarities. The similarity is that, again, we're using inverse operations to get the variable by itself, regardless of whether we're solving an equation or an inequality. So we're still using, we're still adding things to both sides. We're still subtracting things to both sides. If we do it to one side, we have to do it to the other. But there's one key difference, and that's when we're solving inequalities. If we multiply or divide both sides by a negative number, we must flip the inequality sign. All right, so again, it's probably a rule you've seen or heard of before, but that's usually where students make the most mistakes, is that they forget this. Let's do a couple of examples just to show you. So if I look down here, to get the x by itself, I'd have to divide by -5. So I divide by -5, and I get x, but instead of having x is greater than, it's going to be x is less than -3. All right, and we can actually test this, right? If you're ever unsure of whether your solution's correct, test your solution to see if it works. So let's choose a number that's less than -3. So I'm going to choose -4, right? That is less than -3. So if I substitute that back in, right, I'm going to get -5 times -4 is greater than 15. -5 times -4 is +20. So I get 20 is greater than 15. Well, that's a true statement, right? 20 is greater than 15. I'm going to erase the work to show you what would happen if we did it the other way, but you can just do this off to the side. You know what? Actually, I will leave it up here. I'll just rewrite it for us. So let's say so now I have -5x is greater than 15. Let's say I divide now by -5. But I forget to flip the sign, so I get x is greater than -3. Well, let's pick a number that's greater than -3. I think an easy one to pick is 0, right? So if I substitute in 0 back in for our x to check, I get -5 times 0 is greater than 15. -5 times 0 is 0. 0 is greater than 15. But this statement is false, right? 0 is not greater than 15. So again, this is just to show you that if you don't flip that inequality sign, you're going to get a solution that does not make sense. So whenever you multiply or divide by a negative number, you must flip the inequality sign. All right, let's just show you one more over here. This is when we have division. So obviously to get the x by itself, I would need to multiply by -3, again to both sides. So I get -18 is greater than or equal to, because I got to flip that sign, is greater than or equal to x. And again, I like to read it starting with my variable. So this one I would read x is less than or equal to -18. I'm not going to go through and show you the solutions because we just did that for the first example, but you could go back and test a number that's less than or equal to -18. Maybe you test -20 and go back in and see if that works. And you would see that it does. All right, let's keep on going. I think we're now going to get some practice with this. This is just filling in what we talked about above. So whenever you multiply or divide both sides of an inequality by a negative number, you must switch the direction of the inequality sign. So now we're going to talk about how to graph inequalities, and then we're going to put the 2 and 2 together. So we will get some practice solving inequalities in a little bit, but I also want to show you what graphing them looks like, so then we can do problems where we both solve and graph. So let's look at 2 inequalities where they're already solved for the variable, so all we have to do is graph them. Number 1 says x is greater than or equal to 3. So I like to draw my inequalities slightly above the number line just so they're easier to read. So I'm going to put my point at 3. Since we're including 3, right, since it's greater than or equal to, that means x is allowed to equal 3. So I put a closed point or a closed dot above 3. Since it's greater than 3, well, you can think about which side contains numbers greater than 3. Is it this side, right, with numbers like 4, 5, 6, 7, etc.? Or is it numbers to this side, 2, 1, 0, -1, etc.? Well, the numbers greater than 3 are going to be the numbers to the right, so that is going to be our inequality graph. All right, let's move on to the next one. This time it says x is less than -2. So again, we're going to go to -2. But this time, x has to be less than, so it cannot include -2. So we're going to put an open point, all right, because it cannot include -2. Now we have to think about, well, which side of this point are there numbers that are less than -2? And it's going to go to the left. What you can do is you can choose a test point. So if you're not sure how to read these, right, what I need you to understand is that you cannot just look at the direction that the inequality sign is going. I know it's pointing to the left and our arrow is going to the left, but that's not always true. And let me show you why. I could rewrite this inequality as -2 is greater than x. This inequality is the same as the blue inequality, right? Because we flipped the x and the -2, but we also flipped the sign. So they mean the exact same thing. However, if you just looked at this little arrow right here, right, you'd say, ooh, that arrow is pointing to the right. So maybe I'm supposed to draw my inequality. Oops, I'm on my eraser. Put that back. Oops, now I'm on red. I need blue. So you may think, ooh, that arrow's telling me I need to go to the right, right? But that's not true, because if you pick a test point, like if you pick 1 and you substitute that in, you would get -2 is greater than 1. But that's not true, right? -2 is not greater than 1. So these numbers do not work for this inequality. So even though the arrow's pointing to the right, you're still drawing your inequality to the left. So if you're unsure of which way to draw it, choose a test point, right? If we choose a test point on this side, let's choose -6. Well, if I look at the blue inequality, I would get -6 is less than -2. Well, that is true. -6 is less than -2. And if I tested it in the red one, -2 is greater than -6, that's also a true statement, right? I'm just reading it in the reverse way. So what I would recommend is that when you're first starting to do these, if you're uncomfortable, if you're not getting the right answer all the time, don't just guess. Don't just guess left or right, because then you're only 50-50 get the right answer. Choose a test point, do that 30 seconds of extra work, and you will know which way to draw your arrow. All right, let's fill in these blanks down below, and then we'll do some more complicated ones. So it says, when graphing inequalities, we use an open point when the sign is greater or less than, and a closed point when the sign is greater or less than or equal to. So whenever you have that little equals bar underneath the inequality, you're going to use a closed point because the number is allowed, or the variable is allowed to equal that number. All right, time to put both of these ideas together. Let me move this up 1 second. Okay, because we're going to be graphing this too. All right, so we're going to solve for x, and, oops, keeps disappearing, and we're going to graph. So pause the video, try to get x by itself, and then you're going to see if you can graph this inequality solution as well. All right, so the first thing I'm going to do is distribute. So I get 5x minus 10 is less than 3x plus 4. I'm going to subtract 3x from both sides. So I get 2x minus 10 is less than 4. I'm going to add 10 to both sides. So I get 2x is less than 14. I'm going to come up here so I have space to graph. So I have 2x is less than 14. Divide both sides by 2. And I get x is less than 7. Okay, so that's our solution in algebraic form, but now we need to figure out how to graph it. Well, I'm going to go to number 7 on the number line. Because it's only less than and not less than or equal to, I'm going to have an open point. And I need the numbers that are less than 7. So that is going to be to the left. What you could do is choose a test point to make sure you're correct. Let's choose the point 0. 0 is always an easy test point. So if I substitute in 0, I get 0 is less than 7. That is a true statement, so I know I chose the right side to draw on. All right, let's do another example. You know, I'm gonna let you all do the next two examples. Just two different types of inequalities. One's a little tough down here with the fractions. It may take you a little longer, but it's doable. And then, of course, you'll graph both solutions. What we're going to do is move on to a little bit of a different concept where we go from a graph to an inequality. So we're just going to do two examples. I have two graphs, and I need to write the inequalities that match them, essentially. So I'm just going to use the variable x because, well, that's the letter I chose. So I'm going to start with x. In this case, I'm choosing numbers that are greater than or equal to 3. Okay, right? I'm including 3 because there's a closed point. So, and the numbers are going to the right of 3, which means greater than. So we have x is greater than or equal to 3. For the one down below, I have 1. But this time, if I'm going to use x, this is an open point. So I cannot include 1. So I can just say x is greater than, but it's not equal to 1. So greater than 1. And that would be my inequality for the second one. All right, so you have a couple up above that you can try. You have a couple down below, similar to the ones we just did with the graphs. I would check those out, attempt those, and if you need help, you can always come to me with questions. But I think that's going to do it for this video. As always, enjoy the rest of your day, and I look forward to seeing you for our next lesson.